Chapter 1, Section 3, Tables of Proportional Relationships. The content objective is students will analyze the relationship between two quantities represented in tables to determine their proportionality. The textbook says this is a 90-minute lesson, so we can figure it's going to take us a couple of days to get through this. And if you take a look at your vocab words, you see we've got 3 new vocabulary terms to come up on this one: proportional, non-proportional, and constant of proportionality. You should pause your recording for a moment so that you can copy these down as something to study on, so you'll be ready for your upcoming vocabulary quiz. Moving forward, this lesson is showing 15 resources, so we have a lot of learning to do, starting off with tables of proportional relationships. Proportional relationships are all around us. Emily sees 2 different advertisements for car rentals. Road Trip's car rental offers a car $19.99 per day with no other fees. Ryan's car rental offers a car for $9.99 plus a $14 per day fee. Proportional relationships always have the same unit rate. One of these is a proportional relationship, one is not. How can you determine which is a proportional relationship? And the answer is the one that only has 2 things being compared: $19.99 per 1 day. That's going to be your proportional relationship. Your other one has that other fee of $9.99 just for the privilege of renting their car, and then you have the $14.99 per day afterwards. So the very first day is not going to be proportional to all the other days that you rent the car. How can organizing information in a table help you determine if the ratios between 2 quantities are equivalent? That's part of what we're going to learn today. Miss Spencer orders pizza for her students at the end of the year to celebrate certain milestones. Miss Spencer is nicer than Mr. Reitz. Mr. Reitz will not be ordering you pizza at the end of the year. Each pizza costs $7. Drag the pieces of pepperoni to complete the table for cost of 1, 2, 3, and 4 pizzas. You pause the recording while you do this and check your answers. Did you get it right? Let's take a look. First off, the 2 pepperoni and the 4 pepperonis are going to go there for the number of pizzas. We know that we were told in the original problem that each pizza here costs $7. So I'm going to take the 7 for the first pizza, and of course 2 times 7 was 14, 3 times 7 is going to be 21, and 4 times 7 is going to be 28. Check our answers. Everything is good there. Now compare the cost and the number of pizzas for each number of pizzas as a ratio in simplified form. Use any method of comparison, however, be able to justify your answers. Let's do a talk about it here. What method did you use to compare the 2 values? What do you notice about the comparisons? So you need to take and pause your recording for a minute, do what it said to do, and then think about those talk about it questions. So, to do what they said to do, comparing them in simplified form, we're going to take and write these. Whoops, got to get my pen back. We're going to write these as fractions or ratios. 1 over 7, 2 over 14, 3 over 21, and 4 over 28. I'm going to take and simplify each one. Now the 1 over 7, it's already simplified. 2 over 14, we can divide top and bottom by 2, which gives us, 1 over 7. Divide 3 over 21 by 3 over 3, and that gives us, 1 over 7. And what happens if we divide 28, the biggest number going to 28 and 4 is going to be 4. That's going to give us, 1 over 7. So it doesn't matter which one of the methods you use, you're going to get the same exact answer in simplified form. And that means that these numbers or ratios are indeed going to be proportional. If you can simplify them and you come up with the same exact answer every time, you're going to have your answer, your ratios are going to be equivalent. The following year, Miss Spencer orders pizzas again. In addition to each pizza costing $7, there is now a $2 charge. Drag the pieces of pepperoni to complete the tables for the 1, 2, 3, and 4 pizzas. Once again, you pause the recording. Make sure you understand that on top of the pizza costing $7, there's now going to be an additional $2 charge for ordering that pizza. Alright, this is what I did. Of course, I need my 2 and my 4 to go here. Next, I'm going to say, well, the pizza was $7 plus $2 gave me $9. 2 pizzas was $14 plus the $2 is $16. 3 pizzas, well, 3 pizzas is $21 plus a $2 delivery is $23. 4 pizzas was $28 plus a $2 delivery was $30. And now once again we have a beautiful ratio table. Everything checks out right, but is it going to be proportional? This time the instructions say compare the cost of the number of pizzas for each number as a ratio in simplified form, just like we did last time. Use any method of comparison. However, you have to be able to justify your method. In other words, you have to have good math supporting your answers. So let's take a look and see what I did. But before I do that, you pause the recording and do what you're supposed to do. So once again, I'm going to take and start off by simplifying my ratios. You can see I got a solid comparison going left to what we did last time. I got 1 to 9, 2 to 16, 3 to 23, and 4 to 30. And we have to simplify each one of these fractions. Well, 1 to 9, that is already simplified. 2 to 16, I can take and divide by 2 over 2, which is going to give me a 1 over 8 ratio. That's not the same as 1 over 9. 3 over 23, that one's already simplified. There's nothing I can do to it. And then the last one, 4 over 30, I can divide that by 2 over 2, which is going to give me a 2 over 15 in simplified terms. And you can see that each one of these answers are totally different. In simplified terms, that should be a 23 right there. In simplified terms, they're totally different numbers. And because they are totally different numbers, then we can say that, well, the problems are not actually going to be proportional. In scenario 1, Miss Spencer ordered pizzas for her students. You've talked about all the 2 scenarios there. You pause your recording and answer, why do you think the simplified ratios are equivalent in the first scenario, but not equivalent in the second scenario? Write down your answer, type done, and then look at the sample answers they gave you. The sample answer that they gave us said the second one had a one-time fee added to the cost of pizza. The first one did not. That's the reason that one was proportional and one was not. And our final part for resource 3 says, how can you organize information in a table? How can organizing information in a table help you determine if the ratios between the pizzas are equivalent? Now take and pause it, type in your answer, and then let's see what the sample answer says. Sample answer says, I can write ratios showing the relationships in tables and then simplify them. I can then compare the simplified ratios to see if they are equivalent. Good, well-written explanation of how to solve these problems. Resource number 4 is where we're going to learn the official definition of proportional. 2 quantities are proportional if the ratios comparing them are equivalent. In the table, all the ratios comparing the cost to the number of pizzas are equivalent and have a unit rate of $7 to 1 pizza. So the cost of ordering is proportional to the number of pizzas ordered. And you can see that if you divided 7 by 1, you got 7. 14 by 2, you got 7. 21 by 3, you got 7. And 28 by 4, you got 7. And that was $7 for what? One pizza. And that's why these are all going to be proportional. They all represent the same ratio. In the relationship where the ratios are not equivalent, the two quantities are non-proportional. Another definition for your vocab quiz. In the table, the ratios comparing the number of pizzas are different, so the relationship represented by the table is non-proportional. 9 divided by 1 was 9. 16 divided by 2 was 8. 23 divided by 3 was $7.67. And 30 divided by 4 was $7.50. These numbers on the bottom row are different costs per one pizza. Therefore, our answer is going to be non-proportional. How can you use ratios to determine if a relationship is proportional? Well, we've talked about it. Take each ratio, simplify it, and if in simplest terms you get the same number, then they are proportional. If in simplest terms they're not proportional, not equivalent, they're not proportional. Carrie earns $8.50 an hour babysitting. Is the amount of money she earns proportional to the number of hours she spends babysitting? And you can see they took and made up a chart here on the side where they are comparing Monday 1 hour, Tuesday 2 hours, so she's babysitting an hour a day. And no, she's not. Each day she babysits an extra hour because all of these add up to be a total of 10 hours. What makes this relationship proportional? That's the question we need to answer. Simple answer is $8.50 for every hour. Hour 1, hour 2, hour 10, they all get the same rate of pay. Therefore, it is proportional. Now to prove this, we're going to start off by making ourselves a table. So you pause the recording, start typing in the correct answers to go on each one of these, and then we'll see what happens after that, okay? Alright, I filled in my section, and when I did, I'm going to check the answers, and all of them are correct, where I've got how much will be earned for each number of hours worked. Now, we can check proportionality by writing each ratio with the same denominator. The most efficient denominator is going to be 1, creating a unit rate out of it, or a unit ratio. Select a card to see the unit ratio for each relationship between the amount earned in dollars. Pause your recording and do this. Alright, so flipping card 1, 0.5 to 1 ratio is 8.5 to 1. Flipping card number 3, because I don't want to scroll down yet, if I divided 17 and 2 by 2, I'd get the same 8.5 to 1 ratio. For card number 2, if I divide 25.5 and 3 by 3, then I'd get the same 8.5 to 1 ratio. And card number 4, if I divided 34 and 4 by 4, once again, I get the same 8.5 to 1 ratio. So, the relationship is proportional because the ratios between the quantities are equivalent and have a unit rate of how much? $8.50 per hour. Check our answers, our answer checks. Let's keep moving. Think of a way that Carrie could be paid so the amount she made was not proportional to the number of hours that she worked. Explain your reasoning. Pause the recording, write that down on paper. What do you think would be a way that she could get paid that is not proportional? Here's my thoughts. What if Carrie's charged them just to show up? She says, you know, my time's worth some money, and if I'm only working an hour, I'm not making as much money as if I'm working 4 hours. So what if I said that just to get me to show up, I want $10. And then after that base $10, I'll charge you $5 an hour after that. That way, I'm at least insured that base pay of $10 plus maybe another $5 for the first hour, $15 just for showing up for my day. That's an example of what you could do is to create a non-proportional relationship, having that extra fee in the front and then the same rate for every hour afterwards. This is where we're going to stop section, or the first part of chapter 1, section 3. When you come back, we're going to jump into resource number 6 and find out whether or not this table does represent proportional relationship.